Ri minus Rm bar into sigma m, this divided by sigma im minus sigma m square, sigma im minus sigma m square, this is equal to Rm bar minus Rf upon sigma m. We take this sigma m on this side and we are in a position to write down this Ri minus Rm bar into sigma m square, sigma m square, this is equal to Rm bar minus Rf. Sorry, Ri bar, this will be equal to, here we have this Ri bar, so this we have this is equal to Ri bar. So this is not Ri, this is Ri bar, Ri bar. Now this again we can write down Ri sigma im minus, this term in the numerator, this can be written like this, Ri minus sigma im upon this term. We have already defined this as beta I. Beta I is equal to sigma im upon sigma m square. You can see this. We have defined this term as beta I earlier. This term beta I is equal to Rim upon sigma m square. Okay? So we replace this by beta I. What is this? Ri minus Ri bar minus Rm upon beta I minus 1. This is equal to Rm bar minus Rf. Ri bar minus Rm. We go for cross multiplication. If we multiply this by this, so this is equal to beta I minus Rm bar plus Rf. Here now what do you find in this equation? This Rm bar gets cancelled out. This is Rm bar. So this Rm bar gets cancelled out. Now what is this equation? The average rate of return on asset I. Now this is equal to Rf plus beta I Rm bar minus Rf. This term beta I is known as beta factor, and this is very important. This beta factor is very important, and we denote this in the equation without I subscript. So this equation can again be rewritten as Ri is equal to Rf plus beta into Rm bar minus Rf. This is what we can again rewrite Ri bar minus Rf this is equal to beta into Rm bar minus Rf. This is what we had tried to prove earlier. Here, not in this, here, this Ri bar minus Rm, beta I Rm. This we had started the proofing this, and finally we have reached at the proof. We are here, Ri bar minus Rf. Let me again, Ri bar minus Rf, beta I, Rm bar minus Rf. So this is the beta factor. Now let us talk about the interpretation of this. This means that this RF factor is known as this RF factor. Asset beta is related to the risk factor because it is covariance variance ratio. So this beta is related to this beta factor is related to the risk factor. And this is nothing, if you look into this, this is the standardized value of the covariance. The standardized, because this is being divided by the variance. The standardized value of covariance between ith asset and the market asset. Between this. Now, this RF is called as this the baseline. This RF is called as the baseline or the return on risk-free asset. Now, what is this difference between termed as RI, the difference between RI bar and RF, the average rate of return in ith asset, and this is the fixed return on fixed asset. So this is called as the expected excess rate of return. Expected excess rate of return on ith asset. Expected excess rate of return on ith asset. The similar reasoning we can say Rm bar minus Rf as expected excess rate of return on market asset. And these two are the expected excess rate of return on ith asset and expected excess rate of return on market asset. They are proportionately related, and the proportion is being given by the beta factor. Clear? So, or in other words, if you say that if we take RF as baseline, the other way of interpreting this is if we take RF as baseline, then the rate of return on ith asset, this is directly proportional to the expected excess rate of return on the market asset. And this is also called, this may be called as premium on ith asset, and this will be called as premium on market asset. Whatsoever you get in excess of the fixed return on the fixed asset, that will be called as premium on that particular asset. So this is about this. Now if we go into this, the market portfolio, the excess rate of return on asset, this we have already talked about. And what is this beta? This beta is nothing but the covariance between I and M upon variance of M. I told you that this is the factor which is responsible, how much excess return will be there on the ith asset. This will be determined by the beta factor, or in other words we can say that this will be determined by the covariance factor. This will be determined by the covariance factor. Suppose if covariance between ith asset and market asset is equal to 0, if sigma im is equal to 0, then in that situation clear. So if this sigma im is equal to 0, this will lead to that the beta is also equal to 0. Then what is this? It states that the capital asset market theorem, the capital asset pricing model, it says that when there is no covariance between ith asset and the market asset, then average rate of return on ith asset is equal to the fixed rate of return, or there will be no premium on the ith asset. This result actually appears to be surprising, that if there is no return on the ith asset, why the investor should take the headache, why the investor should go for this taking this extra burden. Now this is because there is no premium for the risk, or if ri is equal to rf, the other way what we can say that there is no premium for risk, and this is a surprising result. There is no premium for risk. So this is due to the fact because when there is no association between ith asset and the market asset, when beta is equal to, when beta factor is equal to 0, the risk associated with the asset, the market, it is being diversified away. It is being, the risk is being diversified away. Now, with the help of one example, we can see, with the help of one example, we can see how simple it is to calculate the return on ith asset. How simple it is to calculate the return on ith asset. So we'll be using this capital asset pricing model formula, Capm formula will be using for the calculation of this. Now what is this? Suppose the return on the fixed asset RF, this is equal to 8%, and market asset the return is 12%. The standard deviation, let this be, suppose we are taking a hypothetical example. So rate of return, average rate of return on the market, the fixed rate of return is this much on fixed asset, and the standard deviation of the market asset is 15%. Clear? Now from here, the covariance between the sigma im factor, suppose if it is 0.045, then the beta can be calculated as sigma im upon sigma m square. This is equal to 0.045 upon 0.15 whole square. So this comes out to be 2. Now, what the formula we have got? Ri bar, this is equal to Rf plus beta into Rm bar minus Rf. Clear? We apply this formula. Return on ith asset Ri bar, this is equal to the baseline plus beta into Rm bar minus Rf. So return on fixed asset is 8%. So this is equal to 0.08 plus beta we have already calculated. This is equal to 2 Rm bar. This is 12%, 0.12 minus 0.08. So this is equal to 0.08 plus 2 into 0.04. So this comes out to be 0.08 plus 0.08, which is equal to 0.16, equal to 16%. So very easily we are in a position to find out this return on ith asset, provided these informations are, the simple informations are available with us. Now this is all about your capital asset market pricing, where we had started this with this why the investor should invest in a single fund, choose to invest in the single fund. Then we tried to find the relationship with the help of a diagram in the R bar and sigma plane. Then we looked into the issue that this R bar is nothing but average rate of return on the portfolio. What about the rate of return on an individual asset? Then we tried to get an equation for an individual asset. We proved this mathematically, that not only the rate of return on portfolio can be calculated by using the help of capital asset pricing model, but also we can calculate the value of individual uh, average rate of return of an individual asset. This can also be calculated, and we proved this and we reached at this formula. Now in all these formulas, what do we find? The name of this model is capital asset pricing model. What is this term? The term is the pricing model. But there is no use of price anywhere. Like if you look into this equation, is the rate of return, whether it be on ith asset or on the market asset. Or if you go this, here also, what do we find? That it is about the rate of return. So there is no mention of price into all these capital asset pricing model. So the pricing factor is not being mentioned explicitly into any one of the equation. It is not being mentioned explicitly. But if you look carefully, we find it is there. It's not explicitly, but it is implicit within the model. Let us look into this. So what about the rate of return? The rate of return, normally we calculate this as the rate of return is being calculated. Suppose an asset whose initial price is P0, after one time period one gets this P1 amount, so the rate of return is being denoted by P1 minus P0 upon P0. What about this average rate of return? This average rate of return is P1 bar minus P0 upon P0. So this average rate of return, go this into this equation, go into this equation. So this is equal to 1 to beta. Go into this equation, the average rate of return of an asset is equal to, what is this? Ri bar is equal to Rf plus beta Rm minus Rf. We'll be using this equation and replace this rate of return on in asset, this Ri, by this equation Pi bar minus. So what is this? R bar, Ri bar, this is equal to Rf plus beta into Rm bar minus Rf. So what this? This is P bar minus P0 upon P0. This is equal to Rf plus beta into Rm bar minus Rf. So this P1 bar upon P0 minus P0 upon P0. This is equal to 1. So this P1 upon P0, this can be written as 1 plus Rf plus beta into Rm bar minus Rf. Clear? P1 bar. So this is equal to P1 bar divided by so what do you find? So far whatsoever we have studied about capital asset pricing model, it was all in terms of rate of return, but within this rate of return is price is implicit. So this equation can be written for price also. That is why the name is capital asset pricing model. So this is all about your capital asset pricing model. Let me brief you once again about capital asset pricing model. We started with that why investment should be made into single efficient risky fund along with one risk-free fund. Then we tried the theoretical background, we talked about that. Then we tried to look into this with the help of a relationship between R bar and sigma, means the average rate of return and the risk factor. And after this relationship, we get this equation and tried to explain this equation with the help of a hypothetical example. Now the limitation of this is this: we talk about the average rate of return on market portfolio, not an individual asset, because a portfolio constitutes of many assets. So this is not the limitation of capital asset pricing model. Rather, we can also get an equation for this, and here we observe that this can be written in terms of or a proportionate relationship between premium on ith asset and premium on the market assets. And this proportionality is being denoted by the beta factor. What is this beta factor? Beta factor is nothing but the covariance between, or the standardized value of the covariance between ith asset and the market asset. Then we proved this equation. We first wrote down this equation, then we went for this proof on the basis of the concept that we have already studied. And after this, now we explained this, the result, the meaning of these results, and finally we talked about this. All these results are in terms of the expected rate of return on either on the overall asset or the ith asset and the market asset, but it does not talk about the price factor. There is no mention of price explicitly in the equation, and the name of the model is capital asset pricing model. So we said that as rate of return is being expressed in terms of the prices, so this equation can also be solved for the prices. The explicitly it is not mentioned, but implicitly it is there. That is why the name capital asset pricing model is there. So this is all about your capital asset pricing model, and this is all about today's lecture. Thank you very much.